If you are holding out for the absolute peak of smartphone engineering, or if you are wondering whether Apple is finally shaking up its stagnant design playbook, everything changes right now. Look, for the past few years, upgrading your smartphone has felt painfully iterative. You get a slightly brighter screen, a minor camera bump tweak, and a hefty price tag, and you are left wondering where the actual innovation went. But deep inside Apple's Cupertino supply chain, something massive is shifting. Confidential factory logs, major semiconductor blueprints from TSMC, and supply chain manifests coming straight out of confidential late-stage trial runs reveal that Apple is preparing the most radical device overhaul in half a decade. We are talking about the iPhone 18 Pro Max, and if the current roadmap holds true, it completely rewrites the rules of what a pocket-sized powerhouse can actually achieve. Forget everything you think you know about mobile tech pacing, because Apple is tackling every single historical bottleneck head-on. From a completely redesigned internal architecture that forces rival Android flagships back to the drawing board, to structural overhauls that address the biggest complaints power users have voiced for years, this device is not just another yearly refresh. It is a calculated, aggressive statement of dominance. And right now, we are going to break down every single architectural shift, every silicon breakthrough, and every leaked manufacturing detail to show you exactly why this specific release is causing absolute panic among competing tech giants. Let us start with the elephant in the room, because for years, critics and everyday users alike have pointed out that the front face of the iPhone has carried the exact same visual footprint. The dynamic island, while clever when it first launched, has essentially remained a static pill-shaped cutout that eats into valuable media consumption space. Apple engineers knew they had to cross a critical hardware threshold to shrink it without losing the intricate Face ID matrices that keep the ecosystem secure. According to high-level manufacturing schematics leaked from early assembly lines, Apple has finally cracked the hidden sensor puzzle. By restructuring the internal configuration and shifting key optical components, specifically the flood illuminator, directly beneath active display pixels, the physical footprint of the dynamic island is shrinking by roughly 35%. Think about what that means for daily usability. You get a significantly cleaner, more expansive canvas at the top of that massive 6.9-inch LTPO Super Retina XDR display without sacrificing a single millisecond of authentication speed or security. But Apple didn't stop at just shrinking a cutout. The display panel itself is migrating to a brand new generation of ultra-efficient LTPO plus technology. This isn't just marketing jargon, it fundamentally changes how pixels draw power during high refresh scenarios. By dynamically managing pixel-level current distribution with unprecedented precision, the display maintains a buttery-smooth 120 Hz motion fluidity while drastically reducing the parasitic power drain that usually plagues massive smartphone panels during extended gaming or media streaming sessions. When you look at the phone head-on, the visual presentation is sleeker, more immersive, and far more futuristic than anything currently sitting on store shelves. Now, let us transition to the true engine room of the device, because what is happening beneath the glass is where the real industry earthquake is taking place. For the past several generations, mobile processors have hovered around the 3-nanometer manufacturing threshold, hitting physical limitations regarding thermal output and sustained multi-core efficiency. But Apple has secured an exclusive, massive allocation of TSMC's groundbreaking 2-nanometer manufacturing process to build the custom A20 Pro chip. Let that sink in, 2-nanometer architecture. This allows billions upon billions of additional transistors to be packed into a space smaller than your fingernail, resulting in a monumental leap in raw computational output alongside an astonishing reduction in thermal throttling. When you push the phone to its absolute limits, whether you are rendering heavy 8K ProRes video timelines natively on device, processing complex local artificial intelligence models, or running high-end, ray-traced gaming titles at maximum frame rates, the A20 Pro refuses to break a sweat. Furthermore, industry insiders point to advanced packaging methodologies known as wafer-level multi-chip module integration. By physically fusing the high-speed memory modules directly adjacent to the CPU, GPU, and dedicated neural engine on a unified silicon plane, data latency drops practically to zero. The memory bandwidth is widened to staggering proportions, meaning multitasking feels instantaneous and apps remain locked in memory indefinitely. For power users who treat their phone like a primary portable workstation, this silicon upgrade alone renders every previous generation obsolete overnight. Of course, all that raw performance requires a massive amount of stable network infrastructure, and Apple is completely cutting ties with external cellular component dependencies. The iPhone 18 Pro Max introduces Apple's custom-engineered third-generation C2 cellular modem. If you recall the performance gains of their previous wireless iterations, you know they prioritize absolute energy efficiency and rock-solid signal retention in congested metropolitan zones. The C2 modem takes this philosophy and scales it up exponentially. It features deeper carrier aggregation capabilities, lightning-fast data handoffs, and an integrated system architecture designed specifically to optimize battery preservation during heavy data loads. More importantly, leaked regulatory filings and carrier briefings confirm that the C2 modem unlocks advanced native 5G satellite connectivity capabilities. We are moving far beyond basic emergency text messaging. The iPhone 18 Pro Max is engineered to handle continuous low-latency data streams, web browsing, and location tracking via satellite networks even when you are miles away from the nearest cell tower. Whether you are traversing remote wilderness regions, traveling across open oceans, or caught in localized infrastructure outages, your communication pipeline remains entirely uninterrupted. Coupled with the brand new N2 wireless chip managing Wi-Fi 7, Bluetooth 6, and advanced spatial handoffs, the device acts as an unshakable communications hub that keeps you locked into the digital world no matter where you are standing on the planet. Let us talk about the camera system, because mobile photography has arguably hit a plateau where most companies simply boost megapixel counts and rely on heavy software sharpening to fake details. Apple is taking a radically different, optical-first approach that completely changes the physical behavior of light inside a smartphone. The 48-megapixel main fusion camera on the iPhone 18 Pro Max is rumored to introduce a true variable aperture system. Think about traditional DSLR or mirrorless cameras. When you shoot in blinding midday sunlight, you step down the aperture to control exposure naturally. When you shoot in pitch-dark environments, you open it wide to flood the sensor with raw photons. Until now, smartphones have been locked into a single, unyielding fixed aperture, forcing software to artificially compensate for overexposure or blown-out highlights. With this physical variable aperture mechanism, scaling dynamically from an aggressive f/1.6 all the way down to f/4.0, the phone physically adjusts its internal blades to control light entry in real time. The physical depth of field in portrait shots becomes authentically cinematic, relying on real optical falloff rather than algorithmic background blurring that often cuts awkwardly around hair and clothing edges. Landscape shots maintain pristine dynamic range with zero digital clipping, and low-light astrophotography or evening street scenes capture rich, authentic tonality without crushed blacks or unnatural noise reduction smearing. Backed up by a periscope telephoto lens offering incredible optical zoom fidelity and upgraded stabilization arrays, this camera array bridges the gap between pocket convenience and professional cinema hardware closer than anything we have ever witnessed before. Naturally, powering all of these bleeding-edge subsystems, the 2nm at 20 Pro silicon, the expansive 120Hz LTPO+ display, the high-performance C2 modem, and advanced optical camera modules, demands a serious power reservoir. Apple has traditionally kept device thicknesses meticulously slim, but for the Pro Max tier, engineering priorities have shifted toward pure, uncompromised endurance. Manufacturing leaks and regulatory compliance documents indicate that the Any 18 Pro Max will feature a noticeably larger battery, pushing past previous thresholds to reach an impressive capacity approaching nearly 5,400 to 5,500 mAh depending on regional configuration variants. Yes, this means the device will be a fraction of a millimeter thicker and a tiny bit heavier than its predecessor, but ask any heavy user if they prefer a razor-thin phone that dies by late afternoon or a powerhouse that easily clears a full 2 days of aggressive usage. The trade-off is an absolute win. When you combine that massive physical energy reserve with the extreme power efficiency of the 2nm chip architecture and the optimized draw of the C2 modem, battery anxiety becomes a relic of the past. Even under grueling workloads, recording 4K video at maximum frame rates, streaming high bitrate media over cellular data, and running navigation simultaneously, the phone simply refuses to quit. Furthermore, fast charging protocols have been refined to push 50% capacity in roughly 20 minutes via updated USB-C power delivery standards, ensuring that when you do finally need to plug in, you are back up to full strength before you can even finish a cup of coffee. Even the exterior physical details and button layouts have undergone rigorous refinement based on user feedback. The controversial camera control button, which debuted on previous generations with complex touch-sensitive haptic swiping layers, has been streamlined based on real-world ergonomic testing. Apple has simplified the mechanism to focus purely on precise pressure sensitivity, eliminating accidental triggers while making fast shutter actuation feel crisp, mechanical, and instantly responsive. The rear glass panel utilizes an updated, seamless ceramic shield finish surrounding the MagSafe alignment ring, creating a unified, frosted texture that feels luxurious in the hand while resisting fingerprint smudges and surface abrasions far more effectively than glossy alternatives. Additionally, Apple is shaking up the color palette, moving away from tired metallic tones and introducing stunning new finishes like a deep, sophisticated dark cherry and a striking light blue alongside classic structural shades. When you step back and look at the cumulative picture of what the iPhone 18 Pro Max represents, it is easy to understand why the tech industry is buzzing with intense anticipation. This isn't just an incremental spec bump designed to encourage a lazy annual trade-in. It is a comprehensive, ground-up reinvention of mobile hardware engineering. From the revolutionary 2nm A20 Pro silicon engine and the game-changing optical variable aperture camera system to the proprietary C2 satellite-ready modem and massive endurance cell, Apple has systematically eliminated every single traditional compromise associated with flagship smartphone ownership.